Alright, welcome to your triangle congruence foldable notes, and let's go ahead and get started. Now before I actually did this foldable, what I did was I went ahead and I pre-cut the flaps on the foldable. So if you want to pause the video and go ahead and do that, you can. But all you need to do is cut along the solid line, and you're going to stop when you get to the dotted line. So I did that for every single one. Alright, now I'm going to turn my paper over, and I'm going to fold it in because it's a foldable, right? And I'm going to fold all the way until I get to the dotted line. So you're going to fold each flap to the dotted line. Alright, that's one side, and here's the other side. And there we go. Alright, so these are the shortcuts, the triangle congruence shortcuts that you need to know, and these are the ones that we explored as we're working with our patty paper and tracing the triangles in class. Alright, so I'm going to start on the top left. The top left we have side, side, side. So if you recall, there was a set of triangles where you copied two sides on two separate sheets of patty paper, and then you put them over each other and you copied them onto another side. So that one was our side, side, side set. So what does side, side congruence mean? Well, side, side congruence means that if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Alright, so let's go ahead and let's match up the triangles that we see right here. So this side, AB, matches with DE, AC matches with DF, and last but not least, BC matches with EF. Alright? Now, not only do we want to write this, but we actually want to write our congruency statement, and you're going to have to do this on your unit exam and on common assessments. So pay attention, close attention to the way I write these. And I'm going to write these in pencil. Alright? So, looking at these pictures, I need to summarize the information that's given in these two triangles. So what I know is that if side AC is congruent to side DF, and side AB is congruent to side DE, and side CB is congruent to side FE, then triangle ABC is congruent to triangle DEF. Okay? So that is side, side, side. Alright? Now, angle, angle, side. Okay? So look at the picture. Notice how we have an angle, and a side. Now, if you're looking at the picture, you should notice that this side is not included between these two angles. So since this side is not included between these two angles, this side is actually excluded, which is why we put the side last, because it's on the outside of the two angles. Alright? So since the side is on the outside of the two angles, it is excluded. Alright? So here's that rule. The rule is if two angles and the non-included side, so non-included, if you want you can write excluded, but I'm just writing non-included. Non-included side of one triangle are congruent to two angles, and the corresponding non-included side of another triangle, then the triangles are congruent. Okay, so let's go ahead and write our statements. The first statement is if angle A is congruent to angle D and angle B is congruent to angle F and side AC is congruent to side DE, then triangle ABC is congruent to triangle DFE. Okay. Next flap. Notice how these two have the exact same letters, but with the side is on the outside because it's excluded. But right here, the angle's on the inside because it's included. So if the letter is on the inside, that means that it's included. But if it's on the outside, that means that it is excluded. So let's look at this one, side, angle, side. And as I open the flap, you should notice that the angle is included or between the two sides. Alright, so angle D and angle A are congruent. Side AC is congruent to side DE, and side AB is congruent to side DF. So notice, the angle is in between its two sides, which is why we put it in between here, but over here, the side was excluded, which is why we put it on the outside. Alright, so let's go ahead and write our rule. The rule is if two sides and the included, remember included means between, angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Alright, so let's write the statement. If side AC is congruent to side DE and angle A is congruent to angle D and side AB is congruent to side DF, then triangle ABC is congruent to triangle DFE. Alright, next one, HL. HL is one that we didn't explore in class, but it's one of our triangle congruence shortcuts. In hypotenuse-leg, in order to use HL, you have to first be looking at a right triangle. So as soon as I open the flap, you should notice that these are right triangles. And the reason I know they're right triangles is because there is a right angle inside of them. Alright, now the rule for this one is as follows. And that is, if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second right triangle, then the two triangles are congruent. Alright, so let's look at this picture, and I'm gonna turn it to the right. If you do not know the structure of a right triangle, what you need to know about a right triangle is that the hypotenuse is always directly across from the right angle. Now, this is the hypotenuse in each of the triangles, and in a right triangle, each right triangle has two legs. This is a leg, and this is a leg. Same thing over here. This is a leg, and this is a leg. So, if you have two right triangles, and the hypotenuse and one of the legs, it can either be these two legs are congruent or these two legs are congruent, then you can say that the triangles are congruent by hypotenuse-leg. So let's go ahead and write down our statement. Our statement is, first, if triangle ABC and triangle DEF are right triangles, comma, and side AB is congruent to side DE, and side AC is congruent to side DF, then triangle ABC is congruent to triangle DEF. Alright, next one, ASA. Now notice, S is different from the other ones. So A and A are including S. So that means when I look at this, ASA, S should be between or connecting these two. Again, when there is a different letter in between two of the same letters, that means that it is in between these two letters. So again, the angle is in between the two sides because it's different and it's in the middle, so it's included. And then down here, the same thing. You have the S, and the S is being included by A and A. Alright, so let's look at the pictures. Notice that the side is connecting the two pictures. So I'm going to highlight the sides first. And since it's in between the two angles, it is being included. Alright, since it's in between the two angles, it is being included. Alright, so the statement goes, if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Alright, so let's write our statement for the picture. First one is, if angle A is congruent to angle D and side AB is congruent to side DF and angle B is congruent to angle F, then triangle ABC is congruent to triangle DFE. Alright, now the last one is going to contain shortcuts that you cannot use. So these would not, the ones that we put underneath here would not prove that two triangles are congruent. So you cannot use these. Alright, so let's open it up and let's write down what we cannot use. The first one we cannot use is AAA. Alright, we cannot use that one. And the next one we cannot use is SSA. Now again, both of these do not work, okay? They do not prove that triangles are congruent, so you cannot use them. Alright, so to help us remember it, we're going to go ahead and we're going to draw a circle. Inside of it, we're going to draw AAA and SSA. And we're going to draw a line going through it because that is not allowed. You cannot use those two. Alright, thanks for watching, thanks for doing your homework, and I will see you in class. Get ready to practice.